Hello, this is Aaron Daffern, creator of the 5-Minute Math video series. We are looking at the 2023 fifth grade STAAR test. I am using a modified version of the item analysis report for the state of Texas. You can follow along by grabbing the QR code on the screen or looking for the link in the description. Each item will be viewed separately, so you can use the bookmarks embedded in the video or jump to any timestamp that you see on the screen. For number one, we are looking at multiplying decimals. This is TEKS 5.3e, a readiness standard in reporting category 2. So we have 681 books, and they each sold for 50 cents, so total amount. All right, so that's going to be pretty simple, right? We've got a uh, total here that we're looking for. We have 681 books, right? So if we were to draw, let's just say 681 of those, and they are 50 cents each. All right, so probably the best thing to do would be multiplication, 681 sets of 50. Now, when we do this, this is going to involve some decimals, and what I'm going to do is I'm going to drop that initial zero, because that's just going to give me a whole row of zeros. So now it's going to look like a 3 by 2 multiplication. You don't really need that leading zero there. All right, so that's going to be pretty easy. That first row is just zeros. It's really that second row I have to worry about. 5 times 1 is 5, right? 5 times 8 is 40. And then 5 times 6 is 30. Add that 4, 34. You add those, 34050. No regrouping necessary. Now I've got 2 digits behind the decimal there, 2 digits behind the decimal in my answer. So $340.50. Right, the answer is B. Let's see how we did across the state of Texas. So we did very well. This was tied for the fourth easiest in the state. Students really got a softball to start off their 2023 fifth grade STAAR test, 76%, right? Over 3 out of every 4 students got this correct. Now, some of these incorrect answers here, you notice that this is the same thing, except that they had a decimal in the wrong spot, right? So we ended up with this, right? So this is what happens if you put the decimal here rather than where it should be here. So some students did all the right work. They just put the decimal in the wrong spot. They need to focus on counting how many digits are behind the decimal in the factors, making sure the same amount of digits are behind the decimal in the product. Then if we do the A and C, you notice it's the same thing with just a decimal change, right? What this is here is if students just aren't regrouping, right? So let's say we do it like this, right? Just 3 zeros. So that's going to be a 5, right? That's a 40, but we're just not going to add that, right? That 4 just kind of disappears. That's how we get this. So it's just a simple calculation error. Not many students did that, right? And you either get A if you put the decimal in the right spot. You would get C if you get the decimal in the wrong spot. So this is a pretty good start for students. Probably just a little bit of extra practice talking about how to know where the decimal goes in the product, making sure you count. I've got 1, 2 digits behind the decimal in my factors, because you have to check both, but there's no digits behind the decimal in that top one. And then make sure there's 1, 2 digits behind the decimal in the product. For number 2, we are simplifying expressions and order of operations. This is TEKS 5.4f, a readiness standard in reporting category 1. So this expression does not have a value of 24, so we need to simplify all of these. We need to make sure we are using our order of operations. So hopefully we are writing, please excuse my dear Aunt Sally. We are remembering that multiplication and division are the same level, so they can be done either order from left to right, same with addition and subtraction, right? So let's just look at these, right? We need to do the parentheses first. This is 33 times 4, right? So that's going to equal 132. Well, that does not equal 24, so that's probably the answer. Let's double check. So always parentheses first, right? So that's going to be 12. 2 times 12. Yep, that's 24. All right, so 12 times minus 8 is going to be 4. So 96. divided by 4. You could do a little long division if you want to, but it's going to be 24. And then I've got my 48 divided by 2. All right, yeah, pretty obvious. My answer here is going to be A. Let's see how we did across the state of Texas. So this was it. Number 2 was the easiest problem on the entire test. Everything gets harder from here. 87% of our students got that correct across the state of Texas. That is fantastic. And you see what the intended mistake was here, right? If you just ignore the parentheses, if you do 36 minus 3 times 4, well, now I've got to multiply first, right? And that's going to be 36 minus 12, which equals 24. But I mean, the parentheses are pretty obvious. And if the students did the work, they're going to notice real quick that these three obviously are all 24. So we did really good on that. So let's pat ourselves on the back. State of Texas. Let's move on to the next problem. For number 3, we are solving data problems. This is TEKS 5.9c, a readiness standard in reporting category 4. So we've got the stem and leaf plot here, and we need to find the difference between the tallest and the shortest. All right, so this is probably something that most of our students should be able to recognize, but we need to see first off the key, right? This is going to act as our tens place. This is going to act as our ones place, right? So the 5 and then the line and then the 4 means 54, right? So what is going to be my tallest? Well, it's going to be on the bottom stem, the final leaf, right? So that's 6, right? That's a 6 and then a 2. So that's just 62. Typically, you can just read these like tens place and ones place. What's my smallest? Well, that's going to be my first stem, first leaf, right? That's going to be 52. Okay, so you can, I mean, you don't even need to set this up. You can eyeball this. What's the difference between 52 and 62? Well, that's going to be 10. That's the difference. So my answer here is B. Let's see how we did across the state of Texas. So this was the 5th easiest. You see 75%. That's full 3/4 of our students got it right. Now, we have a few students that still kind of mess this up, right? So what happens if I just took the difference of the greatest value of each stem, right? So that's going to be 62 and 57, right? That will get you your 5. What if I found the difference of the smallest value, the least value of each stem, right? So that's going to be that 60 and 52. That's going to be that 8. And then if you really want to get kind of wonky, some students found the greatest value of the first stem and then the least value of the second stem. That's the 60 and the 57, right? That gets you your 3. So there's a way to get all 3 of these incorrect answers, but most of our students did a good job. It just takes practice, right? If just reading this, right? Even turning this into a list, if this would help, right? 52, 53, 54, 57. It can be a little bit tiresome, but for some students, they might need that visual of saying, guys, this is all that this represents. What's the difference between the greatest and the least? And so that might be a strategy to help some of our students that are still struggling with understanding how to read a stem and leaf plot. For number 4, we are looking at expanded notation. This is TEKS 5.2a in reporting category 1. Now, we are looking at 3 different expressions. I've got 7 times 10, 3 times 1/10, 9 times 1,000th, and then I just need to find which of these digits have that same value. So there's a few different ways to solve this. I would probably recommend making a place value chart. It looks like 6 digits is going to be my max, so let's just put 6 digits here. Right, so let's put 6 digits. You can write the place value. Since they're kind of giving it to us in values, I'll just write the values underneath. Hundreds, tens, ones, right? Now, I knew that it was the first 3 digits were those 3. Some students start from the decimal and move to the left or the right, right? So ones, tens, hundreds. Now I've got my tenths, got my hundredths, and I've got my thousandths, right? And you can write them either as decimals or you can write them as fractions if you really want to. All right. So now that I've got that, what do I know? I know 7 is in the tenths place. I know 3 is in the tenths place, and I've got 9 in the thousandths place. Now all I need to do is just write these numbers. Let's line them up. My decimal is going to be key, so I'm going to write my decimal here. I got 715. Make sure let's get it all lined up here. Shouldn't be that difficult. All right, so 715,349. You see, my problem is in my hundred spot. All right, so 78. So I need to make sure I start my tens place. 78,039. You see, my problem is right there in my hundredths spot. That 3 needs to be over in the tenths. All right, so 275,369. Hey, that looks good. 7, 3, 9. They're all in the right spot. Let's check this one. 72. Oh, there's my problem right there. That 9 is in the hundredths, should be the thousandths. All right, so my answer here is C. Let's see how we did across the state of Texas. So this wasn't as easy as the last few ones, but not many of them are going to be. This was still easy, though. This was the ninth easiest, 67%. Still a pretty good percentage for our students. And you notice that how I solved the problem, it's going to be very difficult to get it wrong. The students that got this wrong, some chose B and D. Those are the two highest chosen the correct answers. Most likely just eyeballed this. That means they didn't necessarily set up a place value chart. They just look, they're like, look, 7 is in the tens place. That looks good. This 3 obviously is in the wrong spot, but this 9 is in the thousands place. That looks good. And so maybe they just got confused on the decimal right there. And then once again, the 7 is in the tens place. That's easy. That's also correct, right? This 9 is in the thousands. That's the one that's incorrect, but the 3 in the tenths is correct. And so you notice that these two most chosen incorrect answers, they both kind of centered in on this, 7 times 10 is 70, 70 something, 70 something. They didn't really look too much at that's also a 7. It just doesn't lead with it. So rather than eyeballing it, we need to get our students to set up a place value chart. It takes a little bit more time, but it really makes it clear because this one might not be as obvious as some of the kids because it doesn't lead with the 7, but it's still the correct answer because it not only has the 7 in the tens place, has the 3 and the 9 in the correct places as well. For number 5, we are representing equations for multi-step problems. This is a readiness standard, TEKS 5.4b, in reporting category 2. Now, the trick here is something new that we're working on in 5th grade, right, is something that we got exposed to a little bit in 4th grade, but we're really making an emphasis of having an unknown quantity represented by a letter N, but it doesn't really do us much trouble because it's just standing on one side of the equal sign, right? So we can almost treat this as an expression, but other than that, there's no word problem that we need to represent as a multi-step problem. They've already given it to us. We just need to find the value of N, which means we just need to simplify this expression, right? We're going to use our order of operations. So we're going to divide first. Now, that's going to be a little bit of a pain, so let's go ahead and do this. 13, 68, 18 is going to, that's about 20, and that's about 140, so I'm going to try 7. Let's see, 56, that's 126. All right, that's going to work. All right, so what you need to do is you need to make sure that your remainder here, 10, is less than your divisor. If not, I would have had to bump it up a little bit. Let's see, so that's going to be 8. And if 18 times 7 is going to be 126, I'm going to try 6. 18 times 6. There you go, 108. All right, so my answer here is 76, but that's just what this equals. Now I got to add 1. So my answer is B, 77. Let's see how we did across the state of Texas. So this is our first difficult one. This is the 15th most difficult. We barely got over half of our students getting this correct. So what was the most enticing incorrect answer was the 72. Now it's very close to the 77 and 76. We know how we got the 76, right? You just did this 1368 divided by 18 and forgot to add the 1, right? So that's where that one is. This 72 comes from the students not following the order of operations. They would add first, and I don't even know why they would add first, because even going left to right, you would always divide first, right? But they would add first, and this is 1368 divided by 19, right? So this is the overlap between this standard representing an expression or an equation, right, with an unknown quantity. Really, this is an order of operations problem. So hopefully our students saw this and were thinking, okay, so I need to divide first, and then I'm going to add. But almost a quarter of our students did not. Now, how we get this D, 1351, that's if students didn't recognize this as a division. They thought that was subtraction. Maybe the font was kind of small, because it is kind of small on the screen. And they did 1368 minus 18, right? That's 1350. And then plus 1 equals your 1351. So this is just more order of operations, just making sure students recognize this is two steps. Now, maybe they weren't really into 18 into 1368. So maybe this is a division error. And we're just kind of guessing at this point because these three are all close. So it's pretty obvious it's going to be one of these three, right? That doesn't look pretty obvious. So maybe students just had difficulty with this. And so um, we need to practice not only order of operations, but also how to do division when you have a two-digit divisor, because that's probably going to be an issue for some of our students as well. For number 6, we are graphing on the coordinate plane. This is TEKS 5.8c, a readiness standard in reporting category 3. So we've got these 3 points plotted here, and we just need to find the table that best represents this. All right, so let's take a look at these 3 points. Let's find their x and y coordinates. All right, so this is going to be an x value of 2. And now this y value is right in between 40 and 60, so we're going to need to see that's a 50, right? If it's skip counting by 20s, in between the two is going to be a 10. This one's pretty easy, right? This is 4, and then that's going to be 100. And then this is 6, and then my y value is going to be, it's going to be 10 past that 140, because that's the halfway point. That's 150, so that's a little bit tricky since we don't have that. We don't have this 160 sitting up here. So now that I've got those 3 points, take a look at our answer selections here, right? Our answer selections are going to be, well, it looks like the number of bags is going to be on top, so we need to make sure let's go ahead and make our own table here. So number of bags, okay, that's my X. Okay, so that's typically going to be on top. My Y is going to be my charge in dollars, right? That's my Y. So what do I have? My first X value is 2. My first Y value is 50. Second X value is 4. Second Y value is 100. And my last pair is going to be 6 and 150. So now I'm just looking for what looks like this. And B and D are the only two that have at least the 2, 4, 6 up on top. But you can tell B, right, doesn't have the correct Y values. They just kind of counted those midpoints wrong. They call them 45 rather than 50, 145 rather than 150. I've got my correct answer here of D at 5100, 150. So my answer is D. Let's see how we did across the state of Texas. So this one was right in the middle. This was the 17th most difficult out of a 34 question test. That means it's right in the middle. So not many students chose A, but take a look at our incorrect answers. You can see some of the mistakes that students made, right? So we noticed that on B, they just got these two correct on the Y values, right? So they counted this as a 45 as the Y. They counted this as a 145, and that's just recognizing that when you're skip counting by 20s, right, as your interval, you're going to need to make sure your halfway point is a plus 10, not a plus 5. So that's the mistake there. But take a look at C. We had 14% of our students choose C. It's the exact correct numbers. They just flipped them, right? So we need to read our labels and understand that the number of bags is going to be the X value, right? So that's going to be our first values. That's going to be your 2, your 4, and your 6. But this has got your number of bags as your Y value, your 50, 100, and 150. So it's the correct numbers. They just flipped them from the bottom and the top. So this one is a little bit more complicated because we not only had to plot points, but then we had to convert them into a table. So this is a good opportunity for us to give our students real world problems where we have labels on our x-axis and y-axis and take something that's plotted like this, have them do what I did, create their own table. That would be their answer, number of bags. And can they create their own table, charge in dollars, and can they create it correctly? Because most students, they pick up the coordinate plane pretty quickly, but can they manipulate it? And can they turn it into a table, one that's horizontal, but also can they do it vertically, right? So your number of bags would be in the left column because that's your X, and then your money would be in the right column, and then you do that same thing, 2 and 50 and so on. So have them practice taking X and Y values, as long as it's a real world problem, you have labels on your two axes, and converting them into tables. For number 7, we are dividing whole numbers and unit fractions. This is TEKS 5.3L, a readiness standard in reporting category 2. It's a pretty simple expression, 1/8 divided by 4. This is something we work on a lot in 5th grade. Let me visually show you one way to represent this. Some students just remember the shortcut, and that's fine. But if we take our 1/8, right? So let's actually use the lines that we have here. Watch this. I'm going to make 1/8. Okay, so I'm going to make this like this. All right, so I'm going to make my eighths a little bit bigger than I need to because I'm going to break it into fourths, right? So here's my half, half of a half, and then half of a half of a half, right? So you take it, cut it in half 3 times, you get eighths, right? Now I need to divide each of those into 4. Well, watch what happens if I do this. Okay, now I divided that into 4. I divided my eighth into fourths. And I can do the same thing here. I can do the same thing to each of these, right? Let's just take each of these and divide them into fourths. And so I took each of my eighths, divided them into fourths, and then the question is what is one of those going to be? Well, what is that little guy right there? Right, because the red ones are going to be your eighths, and then the blue lines cut each of them into fourths. Well, so there's my eighths, and I cut each of them into fourths. I've got 4 across, I've got 8 down. That's 1 over 32, 1/32. Most students will remember that if you divide by a number, that is the same thing as multiplying by its inverse or reciprocal, right? So instead of dividing by 4, let's go ahead and multiply. Let's make that 1/4. So let's multiply by 1/4. And there you go, multiply straight across. 8 times 4 is 32. So my answer here is A. Let's see how we did across the state of Texas. So this one was tied for the 7th easiest. Most students did a pretty good job on this. 7 out of 10 students got this correct. Now, you see that we do have B as our most incorrect, and most of us probably, that's not a surprise, right? How are we going to get this 1/2? Well, if we didn't really know what to do, right, and you just kind of multiplied by 4, right? Well, that's going to equal 4/8, which equals 1/2, which makes sense, right? You see a 4 and an 8, 4 over 8, that makes 1/2. That's why I recommend, even if students understand that dividing by a number is the same as multiplying by the reciprocal, always draw a representation, right? Because if you take a set of eighths here, and then you divide it by a fourth, that's nowhere near a half, right? So when you're dividing it by 4s, you're not going to get 1/2. You're going to get something much, much smaller. So that would have been kind of your first clue of, okay, that's pretty small. That's not going to be 1/2. That would be taking 4 out of the 8. but that's not what it's saying. So just another opportunity for students to practice dividing whole numbers and unit fractions and practicing making representation, a visual representation to prove your work. For number 8, we are classifying 2D shapes. This is TEKS 5.5a, a readiness standard in reporting category 3. This is the one that says you have to use a graphic organizer. So we've seen all different types of graphic organizers over the years. This one, though, is asking us, and this is a Venn diagram, right? Even though they're not typically, and the way it typically is, to where you're seeing the overlapping circles, right? You do see showing sets and subsets. We typically think of this as a Venn diagram, but it also can be this. All this means is that the shaded is going to be completely within acute, which is going to be completely within triangle, right? Before I even read the question, the fact that this acute triangles, this circle is sitting inside the larger triangle circle, this lets us know that every single acute triangle is a part of this larger circle, which is a triangle. That's fine. That makes sense. You're not going to get an acute triangle. It wouldn't make sense if you did it over here, that you would do it. There's some acute triangles that are triangles, and there's some acute triangles that aren't triangles, right? That's not going to make any sense. So you can have the circles within each other. Then you've got a circle within the circle within the circle. So anything that goes in this shaded section right here, it has to be an acute triangle, has to be a triangle because it's completely enclosed. So now let's take a look to see what we have here. Okay, so scalene triangles. I'm going to find a triangle that has to be acute. Okay, so scalene, right? This is by the side lengths here, right? So a scalene triangle has 3 different sides. And basically, I need to see, can I find one that doesn't fit? If I can find one that doesn't fit, then it is going to, you know, not be in there. And yeah, I can easily find, right? I can draw most of my right triangles are going to be scalene. They're going to have 3 different sides. I can even draw an obtuse scalene like this. That looks kind of weird. Let's pretend that's a triangle. Yeah, that's not going to be acute. Okay, acute triangles have all 3 angles, right, are going to be less than 90 degrees. They're all going to be acute. So I need to find a triangle that's always going to have all 3 angles acute no matter what, not scalene. Definitely not right, because by definition, a right triangle can't be an acute triangle because it's got a right angle. So definitely not that one. Isosceles, I can draw some isosceles that are acute, but you know what? I can draw an isosceles right triangle. Let's pretend these 2 side lengths are the same. That's an isosceles right. I can draw an isosceles obtuse. Once again, pretend those 2 side lengths are the same, right? So this is going to kind of be very similar to the scalene. On the isosceles, I'm just making that 2 are the same. So I'm just trying to make at least 2 of the side lengths the same, but I can still do that with right angle. I can still do that with an obtuse angle. Equilateral. Okay, equilateral means all 3 sides are the same. And here's the thing, no matter the size of the side lengths, if all 3 are the same, all 3 of those are going to be 60 degrees. That's what an equilateral triangle is. I don't care whether you make it huge, trying to make all 3 side lengths the same, or small, they're all going to be 60 if it's an equilateral triangle because the angles are related to the side lengths. And so if the side lengths are the same, it is going to have to be 60. That is less than 90. So that is my answer. Equilateral triangles are always going to be acute triangle. They're a special kind of acute triangle. So my answer here is D. Let's see how we did across the state of Texas. So this was tied for the 4th most difficult. Take a look. The most chosen answer was not even the correct answer. The most chosen answer was B, the one that seems obviously the most incorrect. So what's going on here? Well, triangles are tricky. Triangles can be classified by side length, right? And so you're talking side length here. You can talk, equilateral. That's where all 3 sides are the same. You've got isosceles where at least two sides are the same, and then scalene, none of the sides are the same. But then they can also be classified by angle, right? So you can have acute, which is what we were looking for. You can have right, which has one right angle, obtuse, which has one obtuse angle. That's a lot of vocabulary. And knowing that a triangle can be both. You can have a right isosceles, you can have a right scalene, you can have an obtuse isosceles, you can have an obtuse scalene. Now, here's the thing. You cannot have an equilateral right or an equilateral obtuse. These two have to go together. Now, you can have an acute isosceles if you want. You can have an acute scalene, but this equilateral, the only thing that an equilateral can be is acute. So that's kind of the strange thing that we've got here. So this is problematic for students because there's a lot of definitions. Knowing that a triangle can be classified by two different things, both by the side and the angle, right? So this is right, and I also tried to make it isosceles. So this means we need to give students an extra set of practice on how to classify triangles. Always try to classify a whole bunch of different triangles, but try to do it by side length and by the angle. Because look, we have the angle measure right here, but look at the correct answer was the side length. So we switched back and forth between side length, these two are side lengths, and this one. But then we also had an angle measure here, and we also had an angle measure here. So going back and forth between the two, really, it was difficult for students. If you take a look at these answer selections, this really looks an awful lot like guessing. When you see these four, I know this 14% is a little bit below the 25, but when you see answer selections that are all kind of hovering around this 25%, that means probably our students really didn't know what to do and they just guessed. For number 9, we are adding and subtracting fractions with models. This is TEKS 5.3H in reporting category 2. So we have a fractional model here, and x is going to be subtracted from a different fraction, so we just need to figure out what this represents. You see we have a drag and drop here. So first, we need to look at the shaded part, right? Because what it says here is that the shaded part, it represents a fraction. Okay, so what is this shaded part? Well, I see of these big chunks, right? I see the peace sign, right? That means we're going to break it up into thirds. There are two large pieces. So, right, so that's going to be 2/3. And then the x in the model represents another fraction that was subtracted from the first fraction. Okay, so that's going to be 2/3 minus. Then I've got to figure out what that is right here. So this is half of my third here, and I don't really know what this fraction is until I extend this line, right? So what if I break each of these thirds in halves? There we go. Now I've got equal sized pieces. 1, 2, 3, 4, 5, 6. There's 6 pieces. I only took away one of them. So this is really 2/3 of 1 minus 1/6. So there's no A, B, C, or D to choose from. We just need to use our drag and drop. So 2/3 minus 1/6. That's our answer. Let's see how we did across the state of Texas. So this is it. This is the number one most difficult item. Look at this. Only 15% of our students got both points on this. This is a 2-point problem, one for each of these blanks. Now, obviously, this is a drag and drop, not a multiple choice. That's going to make it a little bit more difficult. But if you just wanted partial credit just to get 1 point, all you needed was to recognize that this is 2/3, right? So we should have been able to get more than that 23% plus that 15. So that's what, 38% recognizing that's 2/3. I think this entire problem just threw kids off and they just guessed. Now, not recognizing this as 1/6, we should have been able to do that, but a lot of times what you'll see is you'll see the sixths already completed for the kids, right? So this is typically the model will show. right? And the hard part here is recognizing that these 4/6 equals 2/3, right? So that's sometimes the difficulty is recognizing the larger fraction. But they didn't have that. All they had was just this 1/3 down here broken up into sixths, and then they had to extend that to realize that those were sixths, because without that, you didn't know what the denominator was. I mean, honestly, I could have seen the kid picking 1/4, right? Because there's 4 shaded pieces and there's one of them. And so I think there's a lot of opportunities here to really represent adding and subtracting fractions in a multitude of ways, right? So the first, right, large number here, the whole, the 4/6, that was represented, and they had to kind of represent the 1/6, or the 2/3 was represented, and the 1/6 they had to kind of figure it out on their own. But sometimes, like I said, they will show the sixths and they have to figure out the 2/3. Really, this comes down to equivalent fractions and being able to represent in multiple ways subtracting fractions on this out of the same whole. And how do you show two different denominators out of the same whole? There's a lot of different options out there on release star items. That's what we need to help our students practice on, because visualizing this and finding creative ways to represent two different denominators in the same whole, that's what I think really messed the students up here. For number 10, we are looking at area and perimeter. This is a reporting category 3, a readiness standard, TEKS 5.4H. And so we've got a rug here, and they give us the perimeter, right? So let's just make a rug, right? So P equals 2.4. The length of the rug is 0.8, so let's make this the length right here. So this is going to be meters and meters. And what is the width? I mean, it's just right there. So there's a few different ways we can do this, right? We know that we need to double this, right? So that's going to be 0.8 on this side right here. So what is 0.8 and 0.8? Right, that's 1.6. Now, we need to subtract that from 2.4 to see what's left, right? And then that's going to be 0.8, which is not the answer, but that's probably a very much chosen incorrect answer, because there needs to be 0.8 left between both of those. I got to split that in half, right? So now it's going to be 0.4 on both sides. Because remember, you got to take that 0.8, you got to cut it in half. So it's going to be that 0.4. Or, right, we can do this. We can say P equals double the length plus double the width, right? So my perimeter was 2.4 equals, and then let's say my length is 0.8, 0.8 plus 2W. So that's 2.4 equals 1.6 plus 2W, right? And this is something we do in the upper grades. We isolate the variable, right? But let's just take away the 1.6 from both sides, right? That's going to give me 0.8 equals 2W. And I still have to, that's 2W 0.8. I still have to divide both sides by 2, cut it in half to get my 0.4. Either way you look at it, your answer is A. Let's see how we did across the state of Texas. So this was tied for the fourth hardest. Look, that 30% was the second highest chosen. More students chose this 1.6 than 30. And the one that I thought would be confusing was the least chosen, because probably a lot of students didn't set it up like this, right? If you're not drawing a picture to visualize, then it's going to be easy to make a mistake. Look at this, 2.4 minus 0.8. Now, why are we subtracting? I don't know, because I'm not sure what to do. So I'm just going to take two numbers and subtract it. Oh, look, there's my answer. Why would we subtract 2.4 minus 0.8? I'm not sure, but most likely the students did not draw a visual representation, because if they did, they would have seen, you know what, if that's 0.8, that's 0.8. So maybe they subtracted, maybe they did draw a picture and they added those two and they thought, okay, that's going to be 1.6, but either way, that doesn't help me. And so this probably is something that a lot of fifth grade teachers thought that their students had down pat, but we really start looking at this in third grade, spend a little bit more time in fourth grade, but they don't necessarily have this idea down as to how do you find the perimeter if given just two numbers, the length and the width, or how do you find the length, the width if given the perimeter and then the other? Because this whole idea of doubling it and then finding what's left and then cutting it in half to find a single measurement, that actually involves a lot of algebraic thinking without knowing how to isolate the variable. So this is going to provide teachers and students a lot of opportunity to do problems exactly like this using visual representations and then double checking the work, right? Because if we were to draw a picture here, then obviously if I were to put 1.6 on both sides, well, if I add that up, it's not going to be, my 2.4. It's actually going to be 4.8, way too big. So students can have an opportunity of, just trying to find it, right? If we get this, and then obviously there's my answer, right? Let's double check our work, right? Let's make sure that when we add all of this together, it comes back to 2.4, because if that doesn't work, then we shouldn't be choosing this. So we not only need to try to find the answer, but we need to give our students opportunities and strategies on how to prove their work to make sure they have the right answer. For number 11, we are balancing a budget. This is TEKS 5.10F, reporting category 4. So the Perez family has got $3,620, and we need to figure out what is the greatest amount of money we can put in there and still have a balanced budget. So it all kind of comes down to, what does this word mean? Balanced budget. Well, think about a balance that we might use in science, right? What we want is we want to make sure that we've got this bar in the middle kind of staying even, which means that whatever we put on both sides need to be balanced. If one is heavier than the other, it's going to be out of balance, right? And so we've got our income on one side, then we've got our expenses over here. And if our expenses get to be too big, it's going to be out of balance, right? It's going to end up looking like this, and that's not what we want. So what are our expenses? Well, let's just add this up, and they've got it lined up for us, so there's no need to rewrite it. So that's 5, that's 10. All right, so I'm looking for 10s here. Look, I've got a 5 and 5 is 10. 8 and 2 is another 10, that's 20, 21. And I've got 6 and 4 is 10. And then I'm just going to have to say 12, 13. And then that's 15, that's 19. Okay. 2,910. So how much money does he make, or do they make a month? 3,620, right? So 2,910. Let's see how much more money I could put in there. I'm going to subtract the 2, right? And that's just going to be $710. And you notice how this one's really close. 720 would make it out of balance. It would make it the expense is $10 more than their income. So my answer here is going to be C. Let's see how we did across the state of Texas. So this is right around the middle, tied for the 17th easiest. And you see we had 59% of our students get it correct. I mean, adding these up and subtracting is not that big of a deal. I think the bigger miss here for some of our students was just really understanding what it was asking us to do, right? We've got this balanced budget. I mean, maybe it's obvious that you add them up and subtract from 3620, but with any personal financial literacy standard, you really have a more of a conceptual knowledge rather than just an actual, operation or word problem they're trying to figure out. So this is another opportunity for teachers and students to really drill down to some of these terms like balanced budget, spending, saving, right? Which of these are associated with adding, which of these are associated with subtracting, because these things are very much knowledgeable for us as adults, as teachers, because that's how we live every day. But this is really a new area for some of these students. So really leaning into some of these words and maybe even providing that visual, right, of a balance and bringing out that balance from science class and asking students what they would need to make, right? If your expenses are over here and then your income is over here, and understanding, okay, what would happen if we put the 720 in there, right? Then that would help cement this idea visually for students. For number 12, we are dividing whole numbers and unit fractions with models. This is TEKS 5.3J, reporting category 2. Pretty simple. We need to represent the quotient. If we didn't know what quotient meant, well, they give us the division symbol right there. And we think, oh yeah, that's the answer to a division problem. We need 1/3 divided by 4. Now, the trick here is that at least on 2 of these, right, one of them being the correct answer, they're not going to completely divide it by 4. So we need to just see what each of these problems are. So look, I've got uh, big boxes, right? So I've got 1, 2, 3, right? So that's my, and they're breaking up one of them. So there's my 1/3, and it's dividing into 1, 2, 3. There we go, 4 pieces. So look, right there on A, looks like we're good. Obviously, we're not going to be happy with that. Let's just see what the rest of these look like. And so B is got 1, 2, 3. Okay. So they go ahead and extend these up, right? On B, A didn't do that, which was a little bit of a trick, but it's the same thing. I've still got 3 big slots here, right? I've got 3 big slots, but look what I'm dividing. I'm not taking 1, I'm taking 3. And so really that's going to be divided by, right? I've got that 3, looks like I'm dividing it by 3/4, right? So I'm taking that 1/3, dividing it by 3/4. That's going to be not what we're looking for. Let's look at C. C, they instead of this 1/3, they give me 1/4. Look, this is just pulling the wrong one. So here's my 1/4. We're dividing it into 4 sections, right? And then I've got that, basically, they kind of inverted. This is still 4 sections, but they just divide it by, look, and they take the whole row, so they divide it by, like that whole fourth, right? But it looks like it's 3/3. So I'm not sure what that's representing there. That's going to be kind of weird, but it ends up just being 1/4, right? Because if you divide by 3/3, then that's just going to be 1. And yeah, 1/4 divided by 1 makes that 1/4. So that doesn't really help us there. So yeah, these just don't represent what we're looking for. And it's going to be that 1/3 divided by 4. A is our answer. Let's see how we did across the state of Texas. So this was tied for the fourth most difficult. Look, our correct answer, A, didn't even have the highest percentage of students choosing it. More students chose this D. So what's so tempting about D right here? Well, I was kind of picking out this 1/4 because I was looking for these horizontal bars, but let's just pretend that students didn't even see that. What is this shape? Well, really, this is twelfths, right? If you want to look at it like that, it's really twelfths. Uh, with, same as this B right here, right? They're both twelfths. And you see here that this is, this is 3/12, right? They're both kind of representing this 3/12. They're just doing it in slightly different ways. Now, how do we get twelfths? Well, what ends up happening here is students are just multiplying this 1/3 divided by 4, right? They're keeping that 1/3, and they know that, okay, if I divide by 4, right? That's the same as multiplying by 1/4. They've learned the trick of multiplying by the reciprocal. So we're going to just multiply this by 1/4, and they get this 12th. So I understand that, but here's the problem, right? The numerator should be 1, right? This is the only one that shows that 1/12. This is going to end up being, if you extend all these bars up here, the C is going to end up being 1/16. So they did all of that work, but then they didn't focus on the numerator. So even if you wanted to not necessarily use a picture, to just use this understanding of using the inverse of division to multiply when you're dividing by a whole number, still have to focus on what the numerator is going to be, because 1 times 1 makes 1, not 3. For number 13, we are comparing and ordering decimals. This is a readiness standard of TEKS 5.2b, reporting category 1. We just need to find two comparisons that are true. This is a multiple select, right? So we can't select more than two. If I were to select those two, then it's impossible to select a third. So let's just see. These are going to be helpful if we, rather than looking at them side by side, line them up vertically. That's kind of the trick with fifth grade decimals, is they'll have one go to the tenths and the other to the hundredths, or one to the hundredths and the other to the thousandths. So let's look at these two right here. So like 35.07, 35.70. And we'll see here that this one is greater, but they're saying that the greater one is on the left, so that's incorrect. And that's what we need to do here. Like, look at this, 102.08, 102, that's the easy part, right? They're going to put that 4 right there. And 8 does look like it's bigger than 4, but once we add that 0 to the hundredths place, oh, that's really a 40. 40 is bigger than 8. So that's the greater one, but the greater is pointing to the left, so that's another wrong one, right? So we've got this 3.501, and then 3.5, 501 looks a lot bigger than 5, but we need to add two zeros, and it's still bigger. 501 is just barely, it's 1,000th larger than 500 thousandths, so this one is good, so we'll end up grabbing that third option, and let's see, we got a greater than in all of these, don't we? 909, they're saying is greater than 98, but that's not really 98. Add a 0, it's 980. Definitely bigger, 980, but they've got it pointing in the wrong direction. So let's hope that last one is correct. 37.2 is greater than 37.01. Yes, because that's really a 37.20, and that is greater. So yep, it's our third and fifth options are the correct answers. Let's see how we did across the state of Texas. So this one was tied for the seventh easiest. It's kind of amazing that we're over 70% and it's only the seventh easiest. But take a look what happens, right? If you add our full credit and our partial credit, that's 92% of our students getting at least 1 point. So that's fantastic. So our students did really well on this, even though they're side to side. I would expect most of them probably lined them up. That's probably the best strategy we can teach them, is to always line them up, always, right? If this is a, 1.4 and 1.09, right? Always add that extra 0 afterwards to make sure that they're both going to the same spot. If they can remember that, they're going to easily be able to pass these questions. For number 14, we are dividing decimals. This is a readiness standard, TEKS 5.3G, reporting category 2. So we've got a pretty simple problem here, but they go ahead and give us this word total. So we know that's going to be our dividend here. So we've got a total of, I want to make a strip diagram, 0.87, 3 different computer monitors, right? So each monitor uses the same numbers, so that's equal groups. Whenever we see equal groups, we're thinking multiplication or division. How many watts does each monitor use? Well, I'm going to divide, right, into 3 equal parts here. And so that's what I'm looking for, right? So let's just divide 3 into 0.87. As long as there's not a decimal in our divisor, we're good to go. So let's put our decimal up there, and 3 goes into 8 twice. That's going to be 6. Yeah, pretty standard here. 27. And so 0.29, if we wanted to double check our work, right? 0.29. And then if we just multiplied that by 3 or just added it 3 times, we'll get back up to the 0.87. So our answer here is D. Let's see how we did across the state of Texas. So this was the 13th most difficult, and the actual calculation is not that difficult. It's recognizing what type of problem this was. How did we get 38% of our students choosing C? Well, that's pretty easy. You take your 0.87, you take your 3, you're not quite sure what to do. So let's multiply. Let's see what happens. And look, I find an answer, so that's got to be it. How would that work, though, if we were to draw a strip diagram? That's why strip diagrams are so important, because when that's total, right? You're always putting your total up top. If you were to draw that and then you got 3 computer monitors, right, like I did, how is it going to work to put 2.61 in each of those, right? So this is an opportunity for us to help our students draw a representation. Strip diagrams are a great way to do it. You can even, right, just draw boxes. They each represent a computer, right? And you can say, all right, that's 0.87. Any type of representation is going to let you know, oh, it's got to get smaller because I'm taking that 0.87, dividing it or splitting it up into 3 equal parts. If you were to draw a representation and then try to multiply and plug that 2.61 back into it, it's not going to make any sense. So this isn't necessarily a problem that tripped up our students because the math was hard. It's because they didn't use the correct operation. That goes back to problem solving and reasonableness to double check your work. For number 15, we are looking at unit conversions. This is TEKS 5.7a, reporting category 3. So we have a bag of sand has a mass of 22.7 or 22 and 7/10 kilograms. What is the mass of this bag of sand in grams? Well, in case we're wondering, we've got our reference materials here. And we scroll down and we'll see weight and mass. 1 kilogram equals 1,000 grams. Okay, so that's the conversion that we need. Most of us remember that kilo means 1,000, but so does milli. So sometimes that confuses our students here. So 1 kg equals 1,000 grams. So I have 22.7 kg, right? So if I wanted to represent this in a strip diagram, right, I can draw 22.7 boxes, right? I'm going to kind of just draw like this and say, all right, it goes to 22.7. Inside each of those is 1,000. So I need to do this 1,000, 22.7 times. So most of us are thinking, all right, so that's just going to end up being 1,000 times 22.7, right? And so that's going to obviously just get us this kind of weird number to where that's 7,000. And then that's going to be 0, 0, 0, 2, and then 2 zeros, 0, 0, 0, 2. So you just end up back with this 227, but then you've got 1, 2, 3 zeros afterwards. And then you've got to put the decimal in the right spot, right? So it's going to be 22,700. The trick here is obviously finding where the decimal goes, or most of us have learned when you multiply by 10, 100, 1,000, you could just move the decimal place, right? So for every 0, you get to move the decimal place once to the right if you're multiplying. So it's going to go over once, twice, 3 times, because I've got once, 2, 3 zeros. I've got blanks there. So you put zeros, 22,700. Our answer here is B. Let's see how we did across the state of Texas. So this was tied for the 11th easiest. You see we had 65% of our students get it correct, and all of our errors are just going to be decimal placement errors, like how many zeros do you need to end up with. You notice our second most chosen answer is close. It's just missing 1 0. Now, we did have this option here that not many students chose from, but if you were to divide by 1,000, that means you would move the decimal over 3 times to the left, once, twice, 3 times. So even that 0.227 would have been incorrect. I'd be interested to see what would have happened if they would have put that as one of the answer choices, but they didn't, probably because it has 4 decimal places, and in 5th grade we really only go to 3 decimal places. So this is probably just an opportunity to help students learn a few tricks as to how we multiply by 1,000, right? I mean, if you really wanted to do this 1,000 by 22.7, you could. It's not the most efficient, right? It's helping students understand that when you're multiplying by 10, 100,000, you're just moving the decimal place over 1 time, 2 times, 3 times, each time for a 0 that you have in one of the factors. For number 16, we are generating additive and multiplicative patterns. This is a readiness standard, TEKS 5.4c, reporting category 2. So we have a person running around the track, and we have the relationship. They give it to us here. We don't even have to necessarily make it up ourselves. We've got this y equals 0.25x, right? So if we wanted to put it like this, right? 0.25x equals y. I flipped it because my y is on the right, my x is on the left. So really what you do is you take your x and then you just multiply it by 0.25. That's another way to think about it. It is a multiplicative pattern, multiplying by a decimal. So the answer is going to end up getting a little bit smaller. So what do we need to do here? Well, we just need to, if we see this here, right, we just need to substitute. Right, so if 0.25x equals y, then look at this 7, okay? So then I can do 0.25, but my x is going to be 7. That's going to equal y, which is my missing number. So what's 0.25 times 7? Right, that's the basis of substitution, which we use all through middle school and high school, is substituting in a value in for an unknown, in this case x. So that's going to be 35, right, and that's going to be 14, 17, all right, 1.75. Now this is a drag and drop, so that makes it a little bit more difficult. Let's do the same thing here. I've got 17, so that's going to be 0.25. My x is going to be 17. Let's figure out what my y is. All right, so let's do 0.25 times 17. Now here's the thing. I just did the 7, right? I know that's going to be 175. So then let's just do this one. That's going to be 0.25. I don't need that 0, so there's my answer. That's going to be 5, 12, 4.25, because I got 2 digits behind the decimal, so 4.25. And if you take a look, it also makes sense, right? If we think that we've got, like, take a look at this, 2 times 0.5. So if I double that, that's going to be 4, that's going to be 1. If I add another 0.5, that's going to be 1.5. So that's going to be 6. So it's going to be very close to this 8, which is 2, and it's just a little bit below. If I take this 8 and double it, it becomes 16. If I take this 2 and double it, it's going to be 4. So this 4.25 is just going to be one more above that. So both of those answers make sense reasonably. So I know I've got the right answers. That's 1.75, and that's 4.25. And I always double check to make sure we got it according to what we said. 1.75, 4.25. Yep, those are our answers. Let's see how we did across the state of Texas. So this was the 14th most difficult, kind of towards the middle, but a little bit on the harder side, right? And this is going to be a drag and drop, so we don't know which incorrect answer choices were chosen. But since this is a multiplicative pattern, students didn't even have to use any of this substitution, right? Take a look at this initial relationship. Since they know it's equal groups, 2 equals 0.5, right? All we have to do is look at this. Let's just add a 0 there. 2 what make 0.50? Think of money. And if we think that, we're like, oh, 2 what makes 50 cents? Well, that's quarter. So guess what 1 makes? 1 quarter is 0.25. Once we find this base unit rate here of 25 cents, or just 0.25 for 1, well, then that's going to be pretty easy, right? We can do, and which is obviously what we get right here, but you can see that from the table itself. And then you could just add money, right? So 7 quarters makes $1.75. Right? 17 quarters. It's going to be, 16 quarters is going to make $4, and then an extra quarter is going to be that 25. So if we think of this in terms of money for this problem, you could do this without any type of substitution. So that gives us an opportunities to visualize different ways to solve this problem. For number 17, we are representing equations for multi-step problems. This is TEKS 5.4b, a readiness standard in reporting category 2. And we need to see what our options are here. We can do each of the 4 operations there. And we can do each of the 4 operations there. All right, so now that we know what's in our inline choice options here, let's take a look at the problem itself. And we know it's going to involve an 8, a 3, and a 64. So Gail buys some baseball cards. Okay, so we don't know what the some baseball cards are. And then you see down here, right, she's going to buy H. Okay, so this H is just going to be our unknowns. That's what this is right here. Okay, so the rest is going to kind of describe for us the total baseball cards she has. 1 pack of 8. Okay, so I'm just going to draw pack. I've got 8. 3 more packs that each have 64. Okay, so I'm going to draw 3 packs. I'm not going to draw them proportionally, but I'm going to do 64, 64, 64. All right, so she bought 4 packs, an 8 pack and then 3 64 packs. So one option would be to just do this, right? 8 plus 64 plus 64 plus 64, but I don't have that option. But I need to use an 8. Well, that's easy. That's this right here. And I use a 64. Well, that's easy. But there's 3 of the 64s, and that's where this 3 comes in. All right? So I can represent this as 8 plus, and then I could just represent this as a multiplication problem. 3 times 64. You don't really need the parentheses because if you do order of operations, right, you're going to use the multiplication before you add. You don't necessarily go left to right anyways. So that's what I need. 8 plus, and then it's the 3 times 64. That represents those 3 different packs of 64. So let's get 8 plus 3 times 64. That's our answer. Let's see how we did across the state of Texas. So this was the 16th most difficult, right in the middle of the pack. You see we had 54%, a little bit more than half get full credit, that's 2 points. Another 21% get partial credit, that's 1 point. So put those together, 75% of our students get at least 1 point. Not horrible. I would expect, though we don't know because of the way it's reported, we don't know what the incorrect answer choices were. This is probably the easy one. It was probably this one, not really quite understanding what to do with that 3, because if they were to draw a picture, they would have gotten those 3 64s. Probably, students probably just would have done 8 plus 3 plus 64. Whatever they did to kind of get this incorrect, you're going to need to draw a picture. So whenever we see a problem like this, even if it's just a strip diagram, even if it's just a basic picture like what I did here, the first thing we should do, and we don't tell the students we do this, we model this every time we solve a problem. We should immediately draw a representation somehow rather than just taking the raw numbers and trying to physically manipulate them. If we draw representations as teachers, the students will pick up and say, oh, that's how we solve this. Because if we draw a representation, this becomes easier to see, oh, I've got 3 64s, so this can be 3 times, seeing that basic relationship. For number 18, we are looking at attributes of the coordinate plane. This is TEKS 5.8a in reporting category 3. So we've got 3 points here, and we need to find which of these statements are true. All right, so our options are 3, 1, and 2, 1 and 3, or 2 only. So let's just take a look at these statements here. And point S is located on the horizontal axis. We've got S right here, and S has a Y value, right? If we wanted to plot it, it would be X of 5, Y of 0, but it's got a Y value of 0. And when Y equals 0, that means it is on the x-axis. So that is correct. His horizontal axis is the x-axis because it goes side to side, just like the horizon, where the sky seems to touch the earth. So that is correct. So point Q is located at the origin. All right, so we need to know what the origin is. The origin is where the 2 axes meet, and its point is 0, 0. And you see how Q isn't there. Q is at 1, 1, but that's not where the 2 axes meet. I've got the y-axis here, the x-axis here, and they meet at the origin, which is 0, 0. All right, so statement 2 is incorrect. And then statement 3, point N is the same distance from the origin as point S. Well, we need to know what the origin is. Let's see, point N is 1, 2, 3, 4, 5 up. And then S is 1, 2, 3, 4, 5 over. Yeah, that's correct. They're both 5 away. It doesn't matter if they're the same, if they're in the same direction or if they're in different directions. They're both 5 units away. All right, so we've got 1 and 3. So let's take a look at our options. There we go. Our answer is C. Let's see how we did across the state of Texas. So this was tied for the 17th easiest, right in the middle of the pack here. 59%, almost 60% got it correct. And you notice no one really picked D. Well, a few kids did, but that was the one that was incorrect. So good for us here, but we did kind of struggle here because some of us thought it was statements 1 and 2 only. And so you notice here that 1 and 2, if this was correct and then this one was wrong, that's the exact opposite, right? Both of these included the word origin. So my guess here is that students really didn't know what the origin was, right? And statement 3 had the origin as well. I'm really thinking this is an opportunity for vocab for our students, right? In this problem alone, we had origin, we had horizontal, we easily could have had vertical. And so when we're talking about the coordinate plane, it's not enough just to say, all right, how do you plot this point? Okay, that's something that kids pick up fairly quickly. It's the vocabulary, the conceptual understanding behind it that they need to understand as well. For number 19, we are rounding decimals. This is TEKS 5.2c in reporting category 1. We have the equation editor here, so we just need to provide the answer. And we have just a few clues here. So we have a number rounded to the nearest hundredth is 384.93, or 384 and 93 hundredths. That's what it's rounded to. So the original number is greater than that. So I need a number that is greater than 384 and 93 hundredths, but it rounds down to that. What could be that number? There's more than one possible answer. There's a lot of answers here. Okay, well, let's think about this. If we want to round down to that, if we're rounding to this spot, that means we're looking next door, which means I'm going to need to put something in that thousandths place right there. Okay, so I could possibly put a 1, right? Because if I put that 1, it's going to round. That 1 is not going to change that 3, so we're good. And that 1 makes it greater than, here's our original, right? 384.93, so let's just pretend it's 930. You can always put a 0 in a blank. I could make it a 2, I could make it a 3, and I could make it a 4. Now, if I make it a 5, right, that would change that 93 up to a 94. So then it would be wrong. So if I'm going to just the thousandths place, right, these are my 4 answers. I'm going to type in the whole thing, 384. Let's see, 384 point, and then let's make sure I've got it, 93, and it doesn't matter which of those 4, I'll say 933. Okay, 0.933. But I could have chosen 932, or 933, or 934 if I'm going to just thousandths place. So any of those answers would work. Let's see how we did across the state of Texas. So this was the second hardest problem. Now, this was just an equation editor, so you either got it right or wrong. So we had only 22% of our students get this correct. And it's only worth 1 point here. So it's not like a traditional problem that is one of these new item types that lets you get multiple points. This is just a 1 point problem. So what was it that made it so difficult here? Well, several things. Number one, we had to just conceptually understand that you can have a number that's larger than this that rounds down to that. And all they gave us was this. All right, this kind of goes back to the fundamental understanding of decimals, that you can always add extra digits to the right. So the first thing the students had to do was to start looking in the thousandths place. And if they didn't, because if they didn't look at the thousandths place right, what are their options? Well, they would start changing 94, 95, because they knew it had to be greater, but that wouldn't round to that. So just changing the hundredths place wouldn't work. There's a whole different place value, the thousandths, that wasn't originally given, that students are going to have to get into. Then they have to know the rules about rounding, about what makes it round up and what makes it round down. So this is going to give us a lot of opportunities to really help our kids, and it's not going to be just basic, pure rounding exercises. Most students can kind of perform the logarithm or the algorithm with a little saying about, 5 and up, add one more, 4 and more, or out the door, whatever kind of saying you might have to let them know whether it rounds up or not. What we need are some rounding puzzles, right? Or mysteries, kind of like this, where there's more than one possible answer, and then students would have to provide their possible answer and then defend their answer, discuss why do they think that this works? Can they explain why? And does someone else have a different answer that could also be correct? I love this question, even though it was very difficult, because there's more than one possible correct answer. And so we need to get out of the one question, one answer, and give students the opportunity to practice with some rounding puzzles or mysteries, give them just some clues, and have them figure out what the correct answer could be and then defend it. Number 20, we are classifying 2D shapes. This is a readiness standard, TEKS 5.5a, in reporting category 3. So we have a Venn diagram here. We just have just a word here, polygons with at least one right angle, just a phrase, and we got some pictures that look like parallelograms over there in set B. So which shape most likely belongs at the intersection? All right, so we're looking for the shapes that is going to fit right inside there. So it needs to be, looks like it needs to be a parallelogram, right? Four-sided shape, and needs to have at least one right angle. Okay, so let's take a look at A. Would A work? Is A a parallelogram, two sets of parallel sides? Yeah, the angles are different, but it does have at least one right angle. It's actually got four right angles, right? All four of these, and it's got four sides, two sets of parallel sides. So yeah, A looks like it's good. Look at B. B's not going to work. It's got that right angle, but it only has three sides, and I'm looking for a four-sided shape, so no. C definitely has the right angle, but if we count, right, 1, 2, 3, 4, 5, it's actually a pentagon. So it doesn't fit over with set B because it's got five sides. So B's got three sides, C's got five sides. D, it's got five sides. It's not going to work. So the only quadrilateral parallelogram is going to be A, and that is our answer, the rectangle. Let's see how we did across the state of Texas. So this was the 11th most difficult. We didn't even get half of our students to get it correct here. And take a look at B. We had 28% of our students get B, and obviously it has at least one right angle, so it fits right here. So I think what might have been difficult was since this was in words, right? This was fairly easy, even if we don't know what a polygon is, right? One right angle. Okay, we could get that. But here, I mean, here's the problem, right? B, A, C, D, they all have one right angle. The problem was trying to figure out what is this category over here, the set B, and all they give you are pictures, right? So you could have said a quadrilateral, and that would have been fine because this, the correct answer was the only quadrilateral. But even if it wasn't just a quadrilateral, we could have said parallelogram. Because unfortunately, right, what I could have done is I could have done a right trapezoid, right? And it wouldn't have fit because it's not a parallelogram, though it is a quadrilateral. And so I think the challenge here for students is to label set B, not just take the pictures, but to label them with, a title. They're all quadrilaterals. No, I can get more specific. They're all parallelograms. How specific can you get with set B? Because once they have that, then I know I need a parallelogram with at least one right angle. Well, then it makes it a lot easier if we do that. For number 21, we are multiplying decimals. This is TEKS 5.3e in reporting category 2, which is a readiness standard. So we've got 1.5 cups of sugar for every batch. She makes 3.5 batches. Now there's two different ways we can do this, right? If we're going to make 3.5 batches, right? So I can make one batch, two batch, three batch. I'm going to make that my half, right? So this is going to be 1.5, 1.5, 1.5, and then this is going to be half of 1.5, right? Whatever that happens to be. Well, I can at least add these first three, right? And that's going to be 4.5. So my answer is going to be a little bit more than 4.5. So look, I've already eliminated two answers. Now I think 1.5 is like $1.50. What's half of $1.50? Most of us know that that's okay. Half of $1.50 would be 75 cents, right? Add that 0.75. You can divide if you need to as well. All right, so there's your 525. Now you could do without multiplying. Now, what's a little bit more efficient? Probably multiplying, saying I need 3.5 sets of 1.5 cups, right? So 5 times 5 is 25. That's 15. That's the 17.5. And then I'm just going to put 35 here for my second row. And it's going to be 5, 2. Now here's the only trick. Where does the decimal go? Well, I've got 1, 2 digits behind the decimal in my factors, so I need 1, 2 digits behind the decimal in my product. Either way, your answer here is C. Let's see how we did across the state of Texas. So this was the 13th easiest problem here. And as you can tell by our uh, incorrect answer choices, there wasn't one that really tripped them up. So students, if they didn't know what they were doing, they just kind of guessed, right? Because even if you just added these, right? If you wanted to say, well, I'm not going to multiply because I'm going to read it wrong. If we just add it, you're going to end up getting 5. So that's not one of the answers. Or else that probably could have really messed some kids up. And even if you subtract them, right, you're going to get 2. That's not an answer there. Now, in the demonstration just a moment ago, right, it was easy to kind of draw this picture of 3.5, and that works in small quantities, but really in fifth grade, students should be able to use the standard algorithm, right? So even though this demonstration was a good way to double check your work, it doesn't work if you need 12.5. At a certain point, it becomes a little bit ridiculous, and students need just tons of practice, first recognizing that this is a multiplication problem. And then secondly, how do you multiply? Obviously, you're just multiplying as if it weren't decimals, as if it were 35 times 15. You ignore the decimals when you multiply. You don't have to line them up, but then teaching them however many digits are behind the decimal in my factors are going to be how many digits are behind the decimal in my product. For number 22, we are graphing on the coordinate plane. This is a readiness standard in reporting category 3, TEKS 5.8C. So Jonathan created a multiplication pattern by multiplying each x coordinate by 2 to get the y coordinate. All right, so they want us to make a multiplicative pattern, which is something we work on a lot in fifth grade. So let me go ahead and just give that to you, though. What do they say? Multiply each x coordinate by 2. Okay, so 2 times x is going to get you the y. All right. So what are 2 points that could fit? Multiple answers here, right? Well, what happens? I'm just going to pick some x's, okay? So let's just say x and y, and what I do is I multiply times 2, right? So x times 2. Okay, so what if my x is 0? Well, 0 times 2 makes 0. So I could choose the origin. That is an option. What if my x is 1? Now, I believe I can do half points. Yeah, I can do half points, but I'm not going to worry about that, right? I'm going to just do the wholes. So let's see, if my x was 1, what could my answer be? Well, 1 times 2 is going to be 2, right? So I could do this right here. So x of 1, y of 2. Now I have to turn this into a coordinate pair, right? 1 comma 2. And as you can see, we're kind of going up steep. So eventually what's going to happen is I'm going to have to stop because my y is not going to go high enough because it is going to be double whatever my x happens to be. So what if I did x of 2? Well, if I double my x, right, multiply by 2, I'm going to get 4. So I can get 2, 4. And you notice that pattern there, so that 3 is going to double to 6. So that's going to be 3, 6. Then I'm just going to get 2 more in here, 4, 8. And then technically, right, you could get 5, 10. And then that would work, right? 4, 8, 5, 10. After that, you're off the chart. So any of those could work. You only need two. So I'm just going to do those first two. But you could do these other ones up here if you really wanted to, and you would also be correct. Let's see how we did across the state of Texas. So this was the ninth most difficult problem. We didn't even get a full half of our students, much less than half, to get the full credit, 2 points. And then even if you add how many students got partial credit, 1 point, right, you're really only looking at 60%. So even if you add that, typically you get a lot bigger amount for partial credit. So when you get a full 40% of your students, right, 2 out of every 5 had 0 points on this, this lets you know that there was something about this that was kind of tricky. And I think one of the things was it's just a blank grid, right? You need 2 points and it's just blank. And your only words here are, that give you any clue are going to be right up there. And they have to see that we're doing a multiplicative pattern. So this is where we can, bundle our standards together. So how do we see that this is a multiplicative pattern? Now, I happen to make a t-chart, right, with x's and y's. They don't necessarily have to do that. But some students are going to wonder, where do I start? They don't give me anything, right? Typically in your multiplicative pattern, what do you get? You would get, right, 0, 0, you would get a 1, and then a blank, and then you would get a 2 and a 4, and then maybe a blank and a 6, right? We actually had a problem like that earlier in the test. You would get a partially made one, and then your question is, okay, how do we fill in the blanks? But they don't give you any of that. And so how many opportunities do our students have to actually get a problem like this where it's just wide open? And they have to, first off, derive the pattern here. So 2x equals y, right? Double the x to get the y. Turn that into a number sentence, realize that that's a multiplicative pattern, and then create their own x and y table to plot the points. That's a lot that students have to do on their own without any type of guessing. And if every single problem they get is too structured and gives them too many scaffolds, then they're not going to be able to see a wide open one like this. So let's take a look at some of our 5.8C problem sets that we're doing with kiddos. How can we strip away some of the support and make them do more of the thinking in order to set the problems up rather than just filling in blanks, plotting points? Because obviously this is way beyond just plotting points. Like, how do you plot the point 1 comma 2? We're not doing that. We're way beyond that. So we need to make sure our students are practicing problems that are more complicated and more rigorous than that. For number 23, we are recognizing additive and multiplicative patterns. This is TEKS 5.4D, reporting category 2. So we have a drag and drop here. Now, what we'll notice is that this term additive or multiplicative can only be dropped in that first box. And then these last 4 choices can only be dropped in that second box, okay? So they do give us a little bit of structure there. So let's take a look at what we're trying to figure out here. So we have a pattern here, and we're just trying to figure out the statement, right? So we are increasing. Let's figure out the pattern, right? There is a relationship here. So is it an additive or multiplicative pattern? Well, how do I get from 6 to 24? Well, I could multiply by 4, or I could add, I could add 18. Okay, so both of those could work to make 24. Obviously, we need to see what works on the next set. Okay, let's look at our 9. So if I 9 times what makes 27? Oh, that's a problem. Because that's times 4, that's times 3, so that's not going to work. But what about 9, 27, 18 works? Okay, so it looks like it's an additive pattern. Let's see, 15 plus 18. Yes, that makes 33. And then 26 plus 18. Yes, that makes 44. All right, so we have an additive pattern, right? So let's do this right here. So we're going to say that it shows an additive pattern, and it doesn't say plus 18, but we are going to need to recognize that it's increased by 18. Okay, so increased is the same as plus by 18. All right, now that's in embedded in a much larger sentence, right? An additive pattern because each x coordinate is increased by 18 in order to create the corresponding y coordinate. That's a lot right there. But it's additive, and we're plusing 18. We're increasing by 18. Let's see how we did across the state of Texas. So this one was also tied for the 17th easiest, right in the middle of the pack. We see we almost have 60% of our students getting full credit. Now what I find impressive is that 30% get no credit, right? That's the 0 points. And remember, it was a 50-50 chance, even if you didn't know what you were doing. So over here, you did have a 25% chance of getting this correct. Right? There were 4 choices, but there were 50. You had a 50-50 chance because there's only 2 options on that first one. So 30% of our students didn't have any idea here. I think once you recognize this as an XY table, you're like, all right, let's find the pattern. It kind of became self-evident. You notice that most students, if they got one, they're going to get both. So this amount of partial credit is pretty low here, but putting those two together, you're looking at 70%. That's not bad. Not wonderful, but that's not horrible. I think one opportunity here is this whole thing that I just really kind of read at the end really kind of messed some kids up probably. The relationship shown is an additive pattern because each x coordinate is increased by 18 in order to create the corresponding y coordinate. Guys, this is your sentence stem. I would cut this out and I would have the students work on it, finding any type of pattern here. And before they finish, they need to literally verbally out loud tell you using this sentence stem, the relationship shown is, and then they declare it's either additive or multiplicative, and then they tell you why. It's increased by or multiplied by, but in order to create the corresponding y coordinate, they need to be able to verbalize that you're doing something to each x coordinate to create the corresponding y coordinate. Sometimes we don't do that. We just keep it to the numbers. So use this as a sentence stem to give students an opportunity to use academic language when they are reporting their answer. They don't need to just say, oh, this is plus 18. Okay, we don't do plus 18 in 5th grade. That's very simple. We need to be able to put it into a complete sentence showing an additive relationship because each x coordinate is increased by 18 in order to create the corresponding y coordinate. That's more like it. For number 24, we are comparing and ordering decimals. This is a readiness standard, TX 5.2b, reporting category 1. So we have a table here showing y, x, or w, x, y, and z. And we're going to list the classrooms in order from least to greatest. All right, so they do give us this here, least to greatest. And then we want to know which one is listed second. Ooh, that's a little bit tricky. So let's make sure we do it correctly here. Okay, so let's go ahead and just list all of these out. 95.13, 94.18. I'm going to make them all vertical because I want to make sure they're all going to the correct spot here. And that means let's add a 0. So we go to the 100th spot. Same with this one, 94.7. Let's add a 0. That way, it's much easier to compare and order. All right, so when I'm comparing and ordering, right, I'm going to rewrite these from least to greatest. All right, so 94 and 94 are going to be smaller than 95, and then 94.18 is going to be my smallest, and then that's my second one, 94.70. If I wanted to finish out, I then get my 95s, and 13 is smaller than 20. So there's my list, but I'm looking there for the second one, so that's 94.70, which is this Z here. So my answer is D. Let's see how we did across the state of Texas. So this was the 10th most difficult problem. Look, we couldn't even get half of our students to get this correct, and each of these incorrect answers kind of tells a story, right? So if you chose A, classroom W, that probably means you went from greatest to least. Because if you go from greatest to least, right, this is going to be your greatest one, right? the 95.2, and then that's going to be your second, right? So 21% of our students did all the work. They recognized the decimals and the tenths and the hundredths, and they didn't read whether it's least to greatest or greatest to least. And then classroom X and Y, right? Classroom Y is also going to be greatest to least, but this is going to be something in which students here don't quite understand. Look at this, 95.13 and 95.2. They don't recognize that as 95.20. They think that 95.13 is greater than 95.2 because 13 is bigger than 2, but they don't recognize that that 0 makes that a 0.20. So that's how you would get this classroom wise if they did it from greatest to least and then they didn't recognize that. And that's going to be the same thing with classroom X, right? They're going to think that 94.18, right, is going to be greater than, right? Or actually, we're doing, let's see, they're doing it correctly here. So yeah, we're doing least to greatest, yeah. And they're going to think that this 94.7 is going to be less than 94.18. That's what they're looking at for this classroom X right here. Because we're going least to greatest. They think 7 is less than 18. They don't realize that 7 is really a 70. So you got to flip those, obviously, to get the classroom Z is correct. So lots of opportunities to help our students practice. First, let's always identify greatest to least, least to greatest. But then secondly, how do you compare these two? 94.7 and then 94.18, right? 18 is bigger than 7, but really this is a 70. We always want to make sure our students are making sure all the decimals go to the same decimal spot because 70 and 18 is a lot easier to compare than 7/10ths and 1800ths. For number 25, we are multiplying 3-digit by 2-digit numbers. This is TEKS 5.3b in reporting category 2. So there are 127 rows, 53 apples on each row. This is pretty clear multiplication problem. We've got this word each, right, letting us know that we're dealing with equal groups. And then if you take a look at all of our answers, all of our answers are much bigger than either 127 or 53. So even if I wanted to add them, that's not an answer. So the question is, all right, how do we multiply these numbers, right? And so most of our students are going to just kind of get the, the standard algorithm. But even if I wanted to estimate, just to kind of begin with, right? So let's just say, all right, so let's just round out to the hundreds. Let's round that to the tens, right? So that's going to be 5. And I got 1, 2, 3 zeros. Okay, so about more than 5,000, right? So I'm automatically getting rid of those two because I had to round each of those down and I already got 5,000. So students could estimate and easily make it a 50-50 chance here. But let's see, 7 times 3 is 21, 2 times 3 is 6, add the 2 is 8, and that's 3. Add the 0, right, and that's going to be 35. 5 times 2 is 10, add the 3 is 13. 5 times 1 is 5, add the 1 is 6. And let's just add it up, 13, 7. All right, so 6731, it is one of those two. My answer here is C, and let's see how we did across the state of Texas. This was the second easiest problem. Good job, Texas. 80% of our students got this correct. Now, one thing, it would have been nice, even if we only got 80%, if the other 20% were up here, I kind of could have understand this because these two don't make sense if you estimate, right? And actually, a better estimate would have been rounding both to the tens place, right? That 130 and that 50, right? And we just could have done drop the zeros. We could have done 13 times 5, right? That's going to be 65, and then add those two zeros back. We could have easily got that. We would have seen that it would have been better to get C. So this is an opportunity to help students estimate because these two, B and D, they just don't really make any sense in that context. In order to, get B, what do we have to do? We have to multiply 127 times 53, right? Watch this. So that's going to be 21. We got that's 6, that's the 8, that's the 3. But we don't put the 0 as the placeholder. We just go straight into 5 times 7 is 35. That's going to be 10, that's 13. And that's your 6. And look what I get. So we still have some students, 8% of our students, not recognizing that this 5 is in the tens place. So I need to put a 0 in that second row. And then, you really kind of have to do things backwards, right? Like do 53 times 127, and then not use two zeros as your third line when you're multiplying by 1 to get that 1961. But that's just kind of a random guess there. But overall, we did pretty good. Let's just emphasize the fact that since this 5 is in the tens place, you're going to need a 0, and then everything gets shifted over. For number 26, we are identifying prime and composite numbers. This is TEKS 5.4a in reporting category 1. So we just need to find which of these are composite. And if we don't know what that word means, that we are just going to be guessing here. So a composite number is always kind of in contrast with a prime number. So what's the difference? So a prime number only has two factors, right? So we're dealing with multiplication there, 1 and itself. So a composite number has 3 or more factors, 3 plus. All right, so let's just figure out how we can multiply. Let's take each of these 3. Okay, so how do we get to 3? 1 times 3, and that's it. The only way to get to 3, well, if you multiply, is 1 times 3, which means that it's prime because it only has two factors, 1 in itself. So this is prime, that's not it. 4. Let's see, 4, I could do, obviously, always start with a 1 times itself, but I could do 2 and 2. So my factors here are 1, 2, and 4. I only list that 2 one time. So it's got 3 or more factors. That's composite. Let's check 19. How do I get to 19? 1 times 19, you go through 2 times something, 3, 4, 5, 6, 7, all the way up to 19. 19 is prime. The only way to get to 19 is 1 times 19. It's not a multiple of anything else. So we're not going to do that one. Let's say 22. Well, you should already say 22 is going to be composite because it's even. If it's even, you can always do 2 times something, right? The only even number that's prime is 2 itself. But any even number can be multiplied by 2 and something else. So 2, and that's it. It's just got 4 factors. So that's my other composite number. 31 is also going to be prime because it's odd. And the only way to get to 31 is 1 times 31. You can't multiply anything by 2, 3, 4, 5, 6, 7, anything else to get up there. You get close, but not quite. So my answer here is 4 and 22. Let's see how we did across the state of Texas. So this was another one tied for the 17th easiest, right in the middle of the pack. We got that 59%, almost 60%. This is pretty straightforward, right? As long as our students knew, the difference between prime and composite, then knowing the vocabulary going in, how to solve this problem by identifying the factors that go for each of these values takes a little bit of work. Some students might have eyeballed this a little bit and just try to guess rather than doing the work of listing out all the factors. But if we can get them to do that, right, make these little T-charts listing all the factors, this is a pretty doable, gettable problem. We don't know which incorrect answers were chosen to see if there's any pattern here. They don't give us that information across the state. But overall, just extra practice on prime and composite. Those are brand new concepts that we look at in grade 5. So this is the first time that they get it, and they will be using it the rest of their mathematical careers. For number 27, we are dividing whole numbers and unit fractions. This is TEKS 5.3L, a readiness standard in reporting category 2. So we have a recipe for a batch of cookies calls for 1/4 teaspoon of salt, and we have a total of 12 teaspoons in a salt container. So how many batches can we make from there? All right, so let's draw my my 12 teaspoons of salt. Let's just go ahead and make let's just make a 3 by 4. All right, so that's going to represent my 12 teaspoons of salt. And I'm just using an area model here. You see that each of these little squares, right, represent a teaspoon. And each recipe calls for 1/4. So what I need to do is I need to take each of these little guys right here, cut them into 1/4. Okay, so the question is how many can I make? Well, I just made 4, 8, 12, 16. Okay, I could just keep going, right? 20, 24, 28, 32, 36, 40, 44, 48. Okay, so it looks like I can make 48 if each of those 12 can make 4, right? And so this is really what we did. We did 12, we divided them into 1/4. Okay, but remember, when we divide, it's the same as multiplying by the reciprocal, right? So that's the same as 12 times, and then you flip it, 4 over 1. Well, 4 over 1 is just 4. 4/1 is just 4. So that's just 12, right? That's just going to be 48 over 1, or just 48. So you can do it mathematically, you can do it with a picture. Either way, our answer here is B. Let's see how we did across the state of Texas. So this landed on the easier side, 12th easiest. We had 63% of our students get it right. And let's just take a look at A and C, because those students were just a little bit confused as to what this was actually asking. And so on A here, most likely you're going to divide 12 by 4 rather than by 1/4. And if you divide 12 by 4, we get a nice even 3. But we didn't divide, right? If this is our section, we didn't divide it by 4 because that would just be 4 whole chunks. That's 4 whole teaspoons. I need 1/4 of a teaspoon, not 4 teaspoons. All right, and then not many students chose D, but let's take a look at C, 16. Not really sure of what to do here for some of these kiddos, so they just saw a 12. And if you add 12 and 1/4, you're going to get 12 and 1/4. I don't see that option, but if you add 12 plus 4, well, you get 16. So that's how you get both of those answers. So this is an opportunity for us as educators to continue to give them these problem situations and just recognize they just need a lot of experience, because when we remember something, right, we're just making connections based on previous experience, previous knowledge. So if students don't have enough previous knowledge with these types of problems, they're not going to be able to recognize this as a problem situation that involves dividing a whole number and a unit fraction. This is what they need to be able to extract. If they can get this, they can easily draw a picture. They can remember that it's the same as multiplying by the reciprocal. But the challenge here is, how do you turn this into this? It's just practice, practice, practice. For number 28, we are simplifying expressions and using the order of operations. This is TEKS 5.4F in reporting category 1, 8 readiness standard. So we've got some pencils. Let's just read to see what we're doing here, because we don't want to start writing numbers down and then not know what to do with them. So I've got some unbroken pencils here. And then I've got 4 boxes with 120 in each, so that's like, what, 480? But there are 6 broken pencils in each box, so I'm feeling this broken and unbroken are going to be important. And then she puts half of all, and that 6 comes out of each of the 120s. She puts half of all the unbroken pencils in a storage cabinet, and then all of that needs to equal the 246 unbroken pencils she puts into the storage cabinet. Okay. Well, this 36 is going to be easy, right? We're just going to stick with that 36 right there. Now, I'm going to take my 36 and I'm going to add the unbroken pencils from each of these 4 boxes, right? So I've got 4 boxes of 120 pencils in each, but inside each of those boxes of 120, I've got 6 broken. She's not doing the broken, so I need to subtract that. But look at that order of operations. If I do 4 times 120, that's 480, and then minus 6, right? That's 474. I don't want that. Inside each of those 4 boxes are 6 broken pencils. So I need to use my parentheses right? Since you multiply before you subtract, to make sure I subtract the 120 minus 6, that's going to be the 114 if we really want to be technical about it, right? Then I'm going to need to use brackets. Since I've already used parentheses, you need to take all of that and then divide it by 2 because it says she cuts in half. So really, right, I'll take the 36 and then 4 times it ends up being 114, add them together, and then divide that by 2. All right, so which one looks close? You notice that C and D are very close, but it does make a big difference whether that 6 is inside the parentheses or outside the parentheses. So D is really the one that we did. Now, if our students are getting stuck on this, right, they did give us a clue. They did say you needed to equal 246, right? All we needed to do here is really just see which of these simplified to 246 using order of operations. Would have been a little bit more work probably, but we could have figured that out as well. So answer here is going to be D. Let's see how we did across the state of Texas. So this was the 8th most difficult. Take a look. We didn't even get 40% of our students getting it right. And take a look at our answer selections right there, 23, 29, right? And if you take some of the students that got it right and put it over here, a lot of those are really close to 25%. So I'm guessing that some of the students that even got it right just guessed rather than getting it out by correct by calculation, right? This really lets me know there's a lot of guessing. Students were really struggling to figure out what to do with this. So a few strategies here, right? When they give you the 246, first simplify all 4 of those. See which one of those equals 246. But honestly, our student should have been able to do that, even though this does involve brackets, right? We need to make sure when we're doing order of operations, we always include brackets, not just a single parentheses, okay? So they get exposed to that double layer of simplification. But also this, boy, these clues were difficult. And a lot of our students, they might have seen one clue and not even 2 or 3. And then you get this half at the very end, right? That might have messed them up because they had to turn that into divide by 2. So this was a really advanced level word problem that they had to transform into a into a representation. And honestly, they didn't even have to give us this right here, right? I think they just gave that as an escape valve in case students had difficulty knowing how difficult that was going to be, turning that into an expression. So we need to give our students more opportunities to, practice turning a word problem into an expression that involves like order of operations. And you can even give them, some basic ones, right? 3 plus 4 times 3, right? Have them create a word problem. Doesn't have to be a big deal. Have them just verbally describe. Can you create a problem situation that would fit this expression? That's a lot harder than simply simplifying that to 15. But if they can do that, then that would help them with number 28. For number 29, we are adding and subtracting positive rational numbers. This is TEKS 5.3K, a readiness standard in reporting category 2. So Ethel and Gustavo ordered a pizza for dinner. All right, so it's going to be a single pizza. So let's draw, right, a single pizza. And just to make it easier, I'm going to make it like a square pizza or a rectangular pizza, okay, rather than the traditional circular pizza. Fourths and eighths. So you know what? I just want to make it, to give myself plenty of room, I'm going to make it 8 down. 2, 4, 6, 8. And I'm going to make it, let's just make it 4 across. All right, so there's my pizza. All right, so Ethel ate 1/4 of the pizza. I'm going to make my 1/4 blue, okay? So let's just cut it into fourths. All right, so this is what Ethel ate. 1/4. Now, Gustavo ate 3/8 of the pizza. Let's make that green. How do we make eighths? Well, I've already got it in fourths, and I need to know the relationship between fourths and eighths, right? If I cut each fourth in half, now I got eighths. And he eats 3 of these eighths. Okay, 1, 2, 3. How much did they eat? Well, 1, 2, 3, 4, 5/8. Now, I could solve that completely with drawing a picture. How do you solve that without? Well, if you do the 1/4 plus 3/8, you can't just add straight across, right? So this 4/12, it's not going to work. You don't just add straight across. You need common denominators. And what we found here, here's my 1/4. We found that 1/4 really equals 2/8, right? You could take your 1/4, cut it in half, and you get 2/8. And so once you get that, well, you get 2/8 and 3/8. That's going to make 5/8. Okay, so that's two different ways to solve it. Our answer here is going to be B. Let's see how we did across the state of Texas. So this was tied for the 11th easiest, and not a surprise. A full 24% of our students, almost 1/4, thought that you can just add straight across. That 1/4 plus 3/8 equals 4/12. Guys, that's not how fractions work. Fractions are units. You need to add the same units together. So fourths and eighths are different units. You need to make sure that the denominators are the same. That's why I always start with a picture, because you can represent it visually. That makes sense before you get into the technicality of, well, 1/4 is really 2/8, right? And then you can add that. That's a little bit more difficult. Draw a picture and add it with a picture. For number 30, we are solving data problems. This is TEKS 5.9c, a readiness standard in reporting category 4. So we've got this scattered plot here. We need to find a fraction of students that score higher than 80 on both math or reading and science. All right, so what do we know about this scatter plot here? Here's my science, and I'm going to draw a line on my 80 right here. All right, so I want kids that scored higher than 80 on the science, and then here's my reading, and here's my 80 right here. And I want kids that scored higher. Okay, so if I'm wanting kids that scored higher than 80 on reading, higher than 80 on science, right? Really what I'm dealing with here then is I want this. Any kid that's in that quarter right there, that quadrant. All right, so we need a fraction. Well, fraction is going to be, right, the the number chosen or the number selected, right? That's going to be our numerator over our total. That's how we represent fractions. So I've got 1, 2, 3, 4, 5, 6, 7 that are above 80 in both reading and science, right? And then let's just keep going. So I got 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. 7/18. That's it. Our answer here is C. Let's see how we did across the state of Texas. So this was the 7th most difficult problem. Take a look. We had almost as many choose B and D than we did on C. So what was the B and D? We'll take a look at this science, right? If we're looking at how many got above 80 on science, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's your 11 right there. Then if you look at how many got above 80 on reading, right? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that if you count this, you're not really even supposed to count this on that because that's on the 80. That's not necessarily, um, above it, but that maybe that's where they got that. This really just kind of makes me think that we have a lot of guessing going on here. Even though this A doesn't have really close to 25%, look at these. We've got a lot of these that are just kind of guessing. This is a strange thing to ask students to interpret a scatter plot, because typically what do we do in scatter plots? Well, in scatter plots, we normally look at a trend line, right? And there's a gap, and we would say, okay, so how many do you think there would be if, if you have 100? But that's not how this scatter plot is set up. The scatter plot is not necessarily designed to show the relationship between the science and the reading score and have you guess a missing, piece of information, a missing dot. And so we just need to provide our students opportunities, different ways to interact with scatter plots. I had never thought of turning this into a fraction recognition problem, but they apparently did. And so this is just one more thing that we can have our students practice with. For number 31, we are looking at decimal division with models. This is TEKS 5.3F in reporting category 2. Now we have a drag and drop. There are 5 different blanks here. So let me show you how the scoring works. This is still a 2-point problem. If you want 2 points, you need to get all 5 correct. If you want to get partial credit, that's 1 point. You need to get either 4 correct or 3 correct. But if you want to get 0 points, which no one wants, but you get 2 correct, 1 correct, or 0 correct. So it's in descending order like that. So we need to see what's going on with Luis and his 2 brothers. They equally shared some waffles, right? And the model shown represents the number of waffles Luis and his brothers each received. And you notice we get an equal group in each one. Here's important. Here's what's important is this key right here. Okay, so this is 1 waffle. So that's 1 waffle, that's 1 waffle, that's 1 waffle. So far they've got 3 waffles. Okay, if I'm adding up those 3. Because we're going to divide, right, which means I'm going to start with my total. Right, my dividend is going to be my total. So how many waffles do I have altogether? Well, those are going to be half a waffles, right? So since we're decimals, we need to know half is going to be 0.5. It's 0.5, 0.5. Okay, so how much does that make? Well, these 2 right here are going to make a whole, and then another one is going to be the 1.5. Okay, so 3 whole waffles. Let's make sure we line up our decimals. And all right, so we've got 4.5 waffles. So I've got 4.5 waffles. How many groups did I divide it into? Divided it into 3 groups. And how many's in each group? 1.5. So I think this is correct. Let's just go ahead and do our division just to double check since there's so many boxes we got to fill in. So 3 goes into 4 once. Yeah, 3 goes into 15 5 times perfectly. All right, so that's what that represents. I've got 4.5 or 4 and 5/10 waffles, 4.5 waffles, basically, divided into 3 equal groups. And I'm going to get 1.5 or 1.5 waffles for each person. That's how we get full credit. Let's see how I did across the state of Texas. So this was the 3rd most difficult problem. Look at not even 25% of our students got full credit, got both points here. And even then, we only had 20% of our students get partial credit. So if you put both those together, only 43% of our students got 1 point. Over half got 0 points. That's a lot of points to leave on the table here. So what made this difficult? Several things. First off, this is drag and drop. We get drag and drop, but holy cow, there's a lot of numbers here, right? Each number may be used more than once, so it might as well be an equation editor because you can use any number. The only thing they did for us is they at least set up the fact that it's going to be, a decimal divided by a whole number equals decimal. They set that up, but you've got every single number, and you can use a number more than once. So there's no guarantee if you just were trying to eyeball this and just trying to look at your 4 answers like you do on a traditional multiple choice. It's not an option. This key made it difficult, right? Because really, what is this? This is 4/4 and this is 2/4, right? So students then had to represent that and say, okay, so that equals 1. So 1 and 2/4, but then I have to make 1 and 2/4. Maybe they recognize that as 1.5, but now we have to translate that into 1.5. So that's a lot of different ways to represent the same quantity, right? And obviously they're looking at translating decimals to fractions in the 4th grade, but really a lot of that is going to be like, 3/10 equals 0.3. This is really a 5th grade problem of saying that 1.5 is the same as 1.5. So that's a big concept that they have to understand. And then even recognizing, okay, it's division. I need to pull out my total. How many total waffles do I have? They might have been able to see 3 and the 1.5 because there's 3 groups, but getting the 4.5 out of all of those took a little bit of work. So there's just a lot of moving parts here. This is a pretty well-designed problem. And the fact that they made it a drag and drop did not make it any easier. So this is something to where we probably need to have our students practice, not necessarily the drag and drop, but I think that it was the key here. I think that it was the representation here that we had to take this 6/4, basically what we had here, and translate that into 1.5. That, I think, provided a challenge for some of our students. So when we're giving them practice problems, let's make sure we give them some strange fractions and have them translate them into a little bit more, normal decimals. For number 32, we are looking at area, perimeter, and volume. This is TEKS 5.4H, a readiness standard in reporting category 3. So we built a rectangular prism using cubes. And so let's draw our rectangular prism here, just so we can kind of get a visual reference. All right, so there's our rectangular prism. Try to make it look 3D. There we go. The volume of the rectangular prism is 96. All right, so the whole thing is 96 cubic inches. Okay. The height is 6. All right, so got 6 inches as my height. And what would be the base? Well, the base is going to be this down here at the very bottom, right? And that's what we're looking for. And what do we know about volume? Well, look, volume for rectangular prism, we could use length times width times height, but base times height is going to be a better formula for us to use. So volume equals base times height, right? And we're looking for the base. So my volume is 96. My base is what I'm looking for. And then I need to multiply it by 6. So what times 6 makes 96? Well, I don't know what times 6 makes 96, but I know I can use inverse operation, right? I can divide 96 divided by 6 to find the other factor. So that's going to go in once. All right, it looks like it's going to be a nice even 16. Okay, so my base equals 16. That's going to be square inches. Now, the answer is not just 16. Now I need to find the correct base, right? So that's going to be a 4 by 4. That's 16, so that works. That's going to be a 3 by 3, right? I'm just counting 1, 2, 3, 1, 2, 3. That's 9. That's going to be a 3 by 1, 2, 3, 4, 5, 6, 7, 8. That's 24. No, sorry. And then a 3 by 5. That's 15. All right, so my answer here is A. Let's see how we did across the state of Texas. So this was the 12th most difficult. We had 48%, just a little bit less than half our students get this one correct. And as we can see here, right, B has a pretty high percentage, just more than C and D together. So what is the confusing thing about B? Remember, this was the 3 by 8, so that made 24, right? So a few different options here. Maybe students didn't necessarily know, right? Maybe they got this far. 96 equals base times 6. And then they didn't know that they could divide 96 by 6 to find that missing factor. So they were just kind of eyeballing it, just saying, oh, that's pretty big. That's bigger than a normal fact. I know, 10 times 6 is 60, 12 times 6 is 72. So it's bigger than that. So maybe they were just looking for something big. Or maybe they just miscounted this because if, for some reason they saw this as a 2 by 8, well, then that's going to be 16 and they were looking for 16. Even though it's a little bit more obvious that A is is the better 16. So I'm thinking the students might have gotten to this part and then they got stuck. They didn't know how to find that missing factor, right? So we need to teach our students in situations like this, right? We can think of fact families, right? The reason I knew to divide is because I knew that each multiplication fact, right? And this is a fact, it's a big one, but it's a fact, has fact family, right? And so we could do it like this, right? We could do 96 divided by 6 equals B, or 96 divided by B equals 6. And this is the equation that's helpful. So knowing that when you're stuck on a multiplication fact, you can divide and you can find the missing factor, that might have been the trick for some of these kiddos. For number 33, we are looking at taxes. This is reporting category 4, TEKS 5.10a. And this one is just basic recognition. There's no operations, calculations involved. So she bought a rug for her home. So let's say she bought it from a rug store. Or, we could say she just bought one at Target or Walmart. So let's envision where she's going to buy it from. So let's say she bought a rug at Target. So what kind of tax is she going to pay? Income tax, payroll, property, or sales? Well, we have to know what these taxes are, part of our personal financial literacy standards. So income tax, right, you pay once a year on your income about all the money that you pay. When your parents say they have to pay their taxes every April 15th, this is what they're talking about, right? The income tax. The payroll tax, that's money that's kept out of every paycheck to pay for a few larger things, such as Social Security, Medicare. Property tax, this is tax on your home. And so it's based on the value of your home. Sales tax, this is what you pay in stores. And so obviously that is going to be what we're dealing with here, whether it's an online store, it's anything time you buy something, you have to pay a little bit of sales tax. The money goes to state government and the federal government and even local governments. So answer here is D. Let's see how we did across the state of Texas. So this was the 8th easiest problem on the test. We had almost 70% of our students get it correct. There's one that kind of tripped them up. Property tax here. Maybe they think rug is property since they own it. But they need to realize that or maybe they just clued in on this word home here rather than the rug. Either way, and this is just conversations with kids. They just need experiences talking about when would they pay this, when would they pay this, when would they pay this, when would they pay this. They have to just know these scenarios because this is a little bit easier for teachers to kind of gloss over since it is just a supporting standard. We don't know if it's going to be tested every year, and because it doesn't involve any calculations. For number 34, we are dividing decimals. This is TEKS 5.3G, a readiness standard in reporting category 2. So this is pretty straightforward. We just need to divide 9.45 by 15, right? And so one thing we can do before we actually get started is take a look, right? Even if we just cut this off, we just say it's 9. 9 divided by 15, right? Well, you're dividing, your divisor is larger than your dividend, which means that's going to be less than 1. So we can go ahead and just, at least eliminate A. So let's just divide, right? We got our 15, we got our 9.45. The only thing we do here is we make sure our decimal is, up on the uh, dividend bar or our quotient bar, and we make sure there's no decimals in our divisor, which there are not. Then we just divide like normal. So 15 goes into 94, I think 6 times. That's going to be 90. Right, and that's going to be 445. Look at that. I mean, it's nice and easy. And so for this, I would definitely recommend, all right, let's just double check. 0.63, 15. I want to make sure it gets back to where I wanted it to be. And so I've got 945, 2 digits behind the decimal. Definitely 2 digits behind the decimal, 945. That's where we started. Okay, so 0.63 or 63 hundredths. My answer is C. Let's see how we did across the state of Texas. So this was tied for the 4th easiest. We ended the test on an easier one, right? We had over 3/4 of our students get this correct. A, right? You see it's the 0.63, so they divided correctly. They probably just put the decimal in the wrong spot. So that's why we had 15% of our students get that. And really, B or D you're not going to get when you divide. So those students were probably just guessing. So really, we just need to probably teach our students that, if we were to get our 6.3 times the 15, and if you you did that, right, you would find 94.5, right? So it just takes an extra second to double check your work through multiplication, but if you did that, you would see, oh, I put the decimal in the wrong spot, and then go back and find the work as C.